Welcome to readmeproject.com. Let's discuss the project about a new coding mode for hybrid video coders based on quantized motion vectors. In this paper, we proposed a new coding mode based on motion vectors quantization. In order to insert this technique in the highly optimized H.264 divided by AVC encoder, we solved some problems regarding the encoding of quantized MVs and the choice on the encoding of the quantized set. The proposed technique can be used within any hybrid video encoder, allowing a different coding mode for any macro block. The key tool of the new mode is the lossy encoding of motion vectors obtained via quantization, while the transformed motion compensated residuals is computed with a high precision motion vector. The motion vector itself is quantized before being sent to the decoder in a rate optimized way. Several problems have to be faced in order to get an efficient implementation of the coding mode, especially the coding and prediction of the quantized motion vectors and the selection and encoding of the quantization steps. This new coding mode improves the performance of the hybrid video encoder over several sequences at different resolutions. In first way, this is a flow for process. First we load our input decode video encoder, then we will first estimate the motion with the help of motion vectors, CMVs, candidate motion vector. Then we will go for the motion compensation. Motion compensation is an algorithmic technique employed in encoding of video data for video compression. For example, in the generation of MPEG-2 files, motion compensation describes pictures in terms of the transformation of a reference picture to the current picture. The reference picture may be previously in time or even from the future. When images can be accurately synthesized from previously transmitted or stored images, the compression efficiency can be improved. The decoder receives the pair E, applies motion compensation to form P and B, and decompresses E to apply to reconstructed ER. Since E and ER are different by the effect of the quantization, then the decoder is unable to reconstruct identically, but it alternatively reconstructed PR equal to P plus ER. The reconstruction quantity is usually measured by the mean square error. P minus P are represented as peak signal to noise ratio. For motion estimation, motion vector is the key element for estimating the motion. Then it will go for quantization and motion compensation. Quantization, that is quantized, and go for again motion compensation. Then also here spatial transformation and quantization is applied. Then inverse spatial transformation, both the motion compensation the output and inverse spatial transformation output is merged here. Then we will got the final encoder. Now let us see the execution of the process. First select main.m file and click run file. This is a MATLAB guide window designed for a new coding mode for hybrid video coders based on quantized motion vector. First I'll load the video. Video is loaded and played here. Then we will go for converting to frames. Video is successfully converted it into frames. Then quantized motion vector is calculated. Quantized motion vector is to calculate the motion estimation. Motion vector is a key element for estimating the motions. And then motion compensation is an algorithm technique employed in the encoding of video data for video compression. For example, in the generation of MPEG-2 files, motion compensation describes pictures in terms of the transformation of a reference picture to the current picture. The reference picture may be previously in time or even from the future. When images can be accurately synthesized from previously transmitted or stored images, the compression efficiency can be improved. Here the decoder refers the pair applies motion compensation to for P and B and decompress E to apply reconstructed ER. Then the QMV values are displayed here and the encoded bit values are displayed here. Then we will go for the compressed frames. From the encoding bits, frames are compressed. It will take some time. Compression done each and every frames automatically. Then we will go for the reconstruction. Data is loading here. These are the compressed frames. This is a reconstructed video. It's placed here. There is no difference from the original and the compressed video. Then we will calculate the MSA and PSNR value for the compressed video, and it will calculate the values. Then our algorithm works properly. Thank you.